Assalamualaikum and good day to everyone. Today, I would like to share a study entitled Benzene Metabolite 1,4-benzoquinone promotes DNA repair mechanism via non-homologous DNA enjoining in mouse bone marrow and hematopoietic stem progenitor cells. Benzene, a common environmental pollutant, has been classified as Group 1 carcinogen by IARC, where it is exposed to people via automobile exhaust, smoking, gasoline, and solvent. Previous studies have shown that benzene is known as hematotoxic and leukemogenic agent, with hematopoietic stem progenitor cell niche being the major target and altered hematopoiesis. However, knowledge concerning the DNA repair mechanism of benzene-induced genotoxicity targeting HSPC's niche consisted of multi-lineages population remains obscure. Therefore, in this study, we would like to elucidate the effects of benzene metabolite 1,4-BQ exposure on DNA repair mechanism in HSPC's niche comprised of myeloid, erythroid, and pre-B lymphoid progenitor. For methodology, bone marrow cells were isolated from mice and cultured for 24 hours before being exposed to 1,4-BQ at several concentrations for 24 hours. After that, bone marrow cells and colony-forming cell assay, such as myeloid, erythroid, and pre-B lymphoid, were analyzed for DNA repair mechanism to look for homologous recombinant repair (HR) for DNA epicasis protein expression and non-homologous DNA enjoining NHEJ for RAD51 protein expression. The first one for non-homologous DNA enjoining NHEJ, the results showed that the expression of the epicasis protein were significantly increased in dose-dependent manner in bone marrow cell and HSPCs for myeloid, pre-B lymphoid, and erythroid following 1,4-BQ exposure. This might be due to the fact that NHEJ prone to error that causes chromosomal aberration that lead to alteration in self-removing and differentiation of hematopoietic stem cell and progenitor cell. Besides, the expression of DNA epicasis protein were significantly higher in myeloid progenitor than in other group of cells. Induction of DNA epicasis and NHEG by benzene metabolite is higher in myeloid that causes DNA mutation and genomic instability that leads to leukemogenesis. Move on to homologous recombinant repair (HR), a significant increase in RAD51 protein expression was only observed in myeloid and pre-B lymphoid progenitors at selective 1,4-BQ concentration. Increase in RAD51 foci suggests that HR in DNA repair mechanism produced as CE, which is a chromosomal alteration that also being reported in toxicity study in workers that exposed to benzene. Myeloid progenitor showed the significantly higher RAD51 protein expression in comparison to other group of cells. HR prone to make an error during DNA repair, hence it can be concluded that myeloid progenitor is more sensitive on the genotoxic effect of 1,4-BQ compared to bone marrow cells and other progenitors. In conclusion, 1,4-BQ exposure induced DNA repair mechanism mainly via NHEJ with remarkable effects on myeloid progenitor. That's all from me. Thank you.